So this will be a solution video for classwork 35. The year right now is, what month are we in? November 2023. So if I'm using this in other years, the number might not be 35, but whatever. It is the video for the DoNow that goes with the Gravity Gizmo lab. It's lab 8 this year. It might not be 8 other years, but this is here, let me write this down so that we know that we're in the right place. So yeah, there we go. This will be the DoNow for the Gravity Gizmo lab. So it's talking about the moon and the earth, and so there are some questions about perigee and apogee and stuff like that. So we're going to be taking a look at that in this video. And then, as usual, this being a lab DoNow, the DoNow is designed to help you out for the lab, so to prep you for it. Okay, so let's look at the questions. So the things that they tell us are the moon takes 27 days to orbit, so that's the period of its orbit, okay. And it says that it gets closest distance to Earth is 2.22 times 10 to the 5 miles. The farthest distance from Earth is 2.53 times 10 to the 5 miles. And so, yeah, 13% difference. Okay, well, what questions are they going to ask? All right, I don't know why this is rotating, but we'll deal with it. Okay, so it says convert perigee and apogee from miles to meters. So let's get those numbers. Perigee, 2.22 times 10 to the 5 miles. And then apogee, the farthest point, is 2.5 something? 2.53. Times 10 to the 5 miles. But we don't deal with miles, we deal with meters. So the first thing we're going to need to do is convert from miles to meters. And hopefully it says here that a mile is 1,600 meters. And so we can use dimensional analysis, cross out the miles, and put in this factor of 1,600 meters per mile. And so when we multiply, we get 355,200,000 meters. Or if we count the number of zeros, count the number of decimal places, that's 3.55 times 10 to the 8 meters. All right, let's convert the apogee number. And we get 4.05 times 10 to the 8 meters. All right, so we converted the miles to meters. Okay, so we have the perigee and apogee in meters, and then I believe number 2 says average the perigee and apogee. Again, I don't know why this is rotating. So average those two, and it'll be the radius of the orbit. So 3.55 and 4.05 times 10 to the 8. There. So 3.55 times 10 to the 8 meters, and 4.05 times 10 to the 8 meters, and it says to average them. So we add them up and we divide by 2. And that's going to be the radius of the orbit, or the separation between the Earth and the Moon. So number 3 says state the masses of the Earth and the Moon. You can find that on page 1 of the ref tab. All right, from the reference table, those are the numbers, page 1. Okay, so then using that, the radius, the separation between the Earth and the Moon, and the masses of the Earth and the Moon, number 4 says solve for the gravitational force between the Earth and the Moon. I don't think there's anything else. Nope. That is our last question. So for solving for gravitational force, gm1m2 over r squared, big G, is on page 1 of the reference tables. All right, so gm1m2 over r squared, I put in big G, I put in the 2 masses, I put in the r that we figured out, Don't forget to square the bottom, and we get 2.03 times 10 to the 20, and this is a force due to gravity, so that would be newtons. All right, done.